Paragraph 1. NASA has just unveiled a new addition to the International Space Station, and experts are calling it one of the most advanced modules ever built. But it's not just about breaking technological barriers. There's a twist here that could redefine how we think about space exploration and what it means for life on Earth. Imagine a future where what happens hundreds of miles above our heads could change the way we tackle problems on the ground, from climate monitoring to global communications. That's the reality. NASA's latest ISS module isn't just designed to improve space exploration, it could change everything. And it's not happening in isolation. It's happening at a time of heightened tension in space exploration, with global powers and private companies racing to establish dominance in space. Paragraph 2. So why does it matter now? Because the stakes are higher than ever, and what's inside this module could shape our future, whether we're ready for it or not. The latest addition to the ISS is more than a module, it is a bold statement about the future. It's about nothing less than our role in space and our ability to use technology to meet unprecedented challenges here on Earth. Join us as we unravel the mystery and purpose behind NASA's latest move, and why it might just blow your mind. Chapter 1. A turning point in space exploration. This latest ISS module isn't just a technological marvel, it's the culmination of decades of breakthroughs, challenges, and perhaps some unsettling unknowns. For years, space agencies like NASA and private giants like SpaceX have pushed the limits of human ingenuity to establish a permanent foothold in space. But along with these advances, a new era of space hazards has quietly emerged. Just a few years ago, concerns about overcrowding in Earth's orbit grew as satellites and debris began to cluster in alarming numbers, raising fears of catastrophic collisions. Paragraph 3. NASA scientists warned of the Kessler syndrome, a chain reaction of orbital collisions that could render parts of space unusable. While this new module is groundbreaking, it has been designed with more than just research in mind. It must also cope with a highly volatile environment where any small miscalculation could threaten the ISS itself. NASA and its partners have designed this module to deal with a growing list of threats: rising tensions with other spacefaring nations, unpredictable cosmic events, and even the potential for man-made disasters. Paragraph 4. But why now? Because time may be running out. As countries step up their efforts to dominate space, this module is both a shield and a gamble. The reality is that no one knows for sure what lies ahead. This innovation may be NASA's biggest leap yet, but could it also be its riskiest? The answer may lie in a surprising twist that could change the way we look at space exploration forever. Chapter 2. The ISS module redefines space innovation. NASA's latest module, known as the Haven Orbital Laboratory, is like nothing we've ever seen before. It's not just an extension of the International Space Station, it's a complete reimagining of what a space module can be. Where previous modules have focused on functionality and survival, Haven is equipped with state-of-the-art specialized facilities that will allow astronauts to conduct advanced experiments with unprecedented precision and control. Paragraph 5. Inside, the module houses next-generation genetics, physics, and space simulation laboratories so precise they can detect molecular changes at the cellular level in real time. This technology will be crucial for studying how prolonged exposure to space affects the human body, critical as we look toward longer missions. And unlike any previous addition to the ISS, Haven is equipped with radiation-shielded chambers designed to protect both astronauts and sensitive equipment from the most dangerous radiation in space. For the first time, astronauts will be able to work in an environment where radiation levels are carefully controlled, allowing for longer, safer missions. Paragraph 6. But the advances don't stop with science. This module offers unprecedented comfort on board, from sleep pods designed to counter the stress of weightlessness to adaptive life lighting that helps regulate astronauts' circadian rhythms. The little luxuries aren't just for comfort, they're strategic, designed to reduce the mental and physical toll of extended missions in space. Perhaps the most groundbreaking addition, however, is Haven's AI-driven system, designed specifically to monitor and adjust the module's environment in real time. From predicting potential hazards to adjusting oxygen levels, this AI is essentially a silent partner in every mission. Paragraph 7. But there's a catch. With all these high-tech features comes an equally high level of risk. Can Haven handle the intensity of deep space, or will this leap in technology also expose astronauts to unforeseen dangers? NASA's Haven Orbital Laboratory is more than just a leap in technology. It is a step that could redefine humanity's relationship with space, with implications ranging from orbit to everyday life on Earth. Paragraph 8. This groundbreaking module has given experts a glimpse of how space innovation can benefit global health, climate science, and even cybersecurity. The Advanced Genetics Laboratory, for example, could uncover new treatments for disease by studying how human cells respond to prolonged exposure to space, potentially transforming healthcare on Earth. On a broader scale, Haven's enhanced Earth monitoring systems are designed to track environmental changes with unparalleled precision, potentially providing critical real-time data on climate change. This technology could revolutionize disaster prediction, giving us earlier warnings of extreme weather events and saving lives and resources worldwide. Paragraph 9. But it's not all opportunity without risk. Haven's AI system, a marvel in autonomous tech, raises questions about dependency on artificial intelligence in high-stakes environments. If this system fails or is breached, the safety of astronauts and even Earth-based systems connected to it could be jeopardized. This module represents the first time such AI has been trusted with life-sustaining functions in space, and experts warn that any malfunction or interference could lead to dire consequences. These advancements have drawn unprecedented alliances between NASA, tech giants, and international space agencies, uniting them in a race to push human capabilities beyond Earth's boundaries. Chapter 3: The High Stakes of Humanity's Frontier. NASA's Haven Orbital Laboratory represents a pivotal moment that could reshape our future. Success would mean new frontiers in medicine, environmental protection, and space exploration. With insights from zero-gravity research, diseases could be treated in ways we once thought impossible, and environmental data from space could enable us to predict and mitigate climate disasters with newfound accuracy. Paragraph 10. This technology has the potential to improve life on Earth and extend humanity's reach beyond our planet. But if Haven falters, the consequences could set space exploration back by decades. A malfunction in this high-stakes module wouldn't only risk the lives of astronauts but might also force us to question the limits of autonomous systems and AI in life-critical environments. The trust we're placing in this technology is unprecedented, and a setback could cast a long shadow over future missions. Paragraph 11. What's more, Haven's success would set new ethical standards for privacy and security, affecting not only astronauts but also citizens back on Earth. With its constant environmental monitoring and AI-driven decision-making, this module pushes the boundaries between global security and personal privacy rights. If this mission is redefining cooperation between private companies and global powers, it is also creating new levels of responsibility for our shared future. Chapter 4: Expert Analysis and Future Projections. Experts are closely analyzing NASA's Haven Orbital Laboratory, weighing its groundbreaking potential against significant risks. Data from space analysts suggest that if Haven is successful, we could see a 30% increase in Earth monitoring capabilities within the next 5 years, which could transform disaster response, agriculture, and resource management worldwide. Paragraph 12. Dr. Elaine Rivera, a senior researcher at the International Space Policy Institute, notes that Haven's capabilities could revolutionize the way we monitor climate, predict natural disasters days in advance, and save thousands of lives. On the medical front, Haven's Genetics Laboratory could enable discoveries in the fight against degenerative diseases, potentially leading to treatments worth billions of dollars a year. But a misstep could have equally far-reaching consequences. Paragraph 13. Dr. Alan Roth, an aerospace engineer with the Global Space Coalition, warns that relying on AI-driven systems in such a critical environment is unprecedented and could lead to cascading failures if even a small error occurs. Roth stresses that a single failure in Haven's automated systems could set off a chain reaction, endangering astronauts and derailing ongoing research. In a worst-case scenario, Haven's AI could misinterpret data in a way that requires a complete mission shutdown, setting back space exploration and putting lives at risk. Paragraph 14. Predictions about wider societal impacts are equally complex. A successful Haven mission could drive investment in AI and space exploration, unleashing a new wave of technological advances across industries. But success on this scale also raises ethical concerns about surveillance capabilities and privacy, especially as space agencies and private companies share unprecedented amounts of data. In addition, experts warn that unexpected outcomes could emerge. Increased reliance on AI could lead to critical vulnerabilities, or new discoveries in space could reshape the healthcare industry, fueling debates about access and ethics. Chapter 6. The Edge of Discovery, Unknowns and Possibilities. With Haven now operational, the stage is set for both groundbreaking discoveries and unforeseen challenges. Scientists are on the verge of new data that could redefine our understanding of the effects of space on human biology. But there's a catch. Early readings from Haven's genetics lab have shown unexpected fluctuations, leaving experts scrambling to determine whether these are early breakthroughs or troubling anomalies. Could this be the start of a new scientific era, or are we seeing signs of deeper unresolved problems? Paragraph 15. Meanwhile, Haven's AI-driven systems, responsible for maintaining life support and environmental controls, have performed well under pressure. However, NASA engineers are watching closely for even the slightest irregularity, knowing that a single miscalculation could spell disaster. So far, the AI has shown remarkable resilience, adapting to slight atmospheric changes with precision. But every decision it makes now raises a critical question. Can we continue to entrust our most advanced missions to a technology that even experts admit they don't fully understand? Paragraph 16. As the module pushes the boundaries of exploration, new obstacles are emerging. Cosmic radiation levels have risen unexpectedly, forcing scientists to find ways to boost the module's shielding in real time. The team has proposed a possible workaround using magnetic fields, a concept that, if successful, could revolutionize future space travel. But the risk is enormous, and failure here could expose astronauts to dangerous levels of radiation. The Haven mission teeters on a knife's edge, with each new insight revealing both a glimpse of success and a potential threat. Paragraph 17. With critical decisions ahead, the next phase promises revelations that could either bring us closer to answers or plunge us deeper into the unknown. Chapter 7. Challenges on the Horizon. As NASA's Haven Orbital Laboratory embarks on this groundbreaking mission, several obstacles threaten to derail its success. One of the biggest challenges lies in the political landscape. Nations around the world are vying for dominance in space, with some rivals seeing NASA's progress as a direct threat. This has sparked debates about resource allocation and competition for orbital real estate, creating potential tensions that could affect international cooperation on future projects. Paragraph 18. However, this rivalry could also lead to unexpected alliances, as spacefaring nations realize the benefits of sharing knowledge and resources in such high-stakes missions. The technical hurdles are equally pressing. Haven's reliance on advanced AI for mission-critical functions introduces a level of risk never before attempted on this scale. Engineers are racing against time to refine failsafes and ensure the AI can adapt to the unpredictable conditions of space. Paragraph 19. This pressure has driven NASA to explore unprecedented solutions, potentially unlocking new technologies that could shape the future of autonomous space exploration. Budget constraints add another layer of difficulty, with each new innovation adding millions to an already strained budget. While these limitations may seem restrictive, they've also led NASA to collaborate with private companies in groundbreaking ways, fostering innovation that likely wouldn't have happened otherwise. Paragraph 20. These partnerships could set a new standard for collaboration between public agencies and private space companies. But as these challenges mount, one question looms larger than ever. Can Haven overcome these obstacles to unlock the secrets of deep space, or will these hurdles be the undoing of one of NASA's most ambitious projects to date? The fate of the mission hangs in the balance. Will NASA's efforts reshape our future or reveal that the cosmos is more unruly than we ever imagined? Paragraph 21. Like and subscribe to stay up to date on this historic journey, where every discovery could change life as we know it. The story is far from over and the stakes have never been higher.